Good morning, everyone. Welcome to the another session on operational amplifiers. Already in previous session, we discussed about some basic information about operational amplifier and block diagram of operational amplifier. And in this today's session, we will discuss operational amplifier symbol, operational amplifier pin diagram, and ideal and practical characteristics of op amp. So operational amplifier is an example for linear IC and it is available in the form of integrated circuit and the IC number for this operational amplifier is 741. So operational amplifier simply called as op amp. So basically it is an integrated circuit and by using this you can performing the different operations. So it is used for various applications like linear, non-linear, mathematical operations. So the name itself, it can perform in the mathematical operations also along with amplification. So the examples for the linear applications are voltage follower, differential amplifier, inverting amplifier, non-inverting amplifier. And non-linear applications are like it is used as rectifier, used as comparators, and it is used in clampers, triggers, etc. And it can performing the mathematical operations like addition, subtraction, differentiation, integrated, multiplication, etc. So basically, this operational amplifier is a direct coupled high gain negative feedback amplifier. So it can amplify the signals in the range of 0 Hz to 1 MHz. This is the range of these input signals. And it can amplify both AC and DC signals. So it is operated for both AC and DC signals. So this operational amplifier is available in the form of IC. That too, in previous session, we discussed different IC packages, means metal can package, flat package, dual inline package. So this is available in the 8-pin dual inline package. So it is having basically in that 8 pins, the 5 basic terminals are, it is having 2 input terminals, 1 output terminal and 2 supply terminals also. This one is the symbol for the operational amplifier. See, in this, it is having the 2 input terminals. So those are V1 and V2 and 1 output terminal V0 and 2 supply voltages. One is positive supply plus VCC and another one is negative minus VCC. So and the input terminals are also having some fixed names. Those are if you are applying input to the negative terminal, that terminal is called inverting input terminal. If this one, if you are applying positive sign, that is called non-inverting terminal. So depending upon the input signal, the output is having that value, means that may be either in phase or out of phase with the input signal. So totally it is having 8 pins. So among these 8 pins, the 5 pins are 2 input pins, 2 supply pins and 1 output pins. And the input pins names are inverting input and non-inverting input. See here, already in last session, discussed about the block diagram. So the block diagram consisting of 4 stages. The first 2 stages are differential amplifiers only. The third stage is the level translator and the output stage is the forceful amplifier. So, and coming to this, it is having 2 input terminals. Those terminals names are inverting terminal and one more is the non-inverting terminal. So the names are basically um, based on the phase relationship between the respective inputs and outputs. So the signal given to the inverting input is always inverted at this output. If whenever we are applying input to this inverting input, the output is the inverted output. And the positive voltage at the inverting input produces negative output voltage. Similarly, negative voltage produces the positive output voltage. But the signal given to the non-inverting input will not produce any sign changes at the output. So this is the pin diagram of the operational amplifier. So operational amplifier consisting of 8 pins. Those are the dual inline package, means it is having the structure is having two lines, two equal lines, and those two are having equal number of pins on both sides. So coming to this first pin, the first pin and fifth pin, these two are called offset null. So these two are used to eliminate the output offset voltage. Generally, by adjusting these pins, we will nullifying the voltage present at the output. Means whenever we are not applying any input voltage, then also it will producing the some output voltage. But by using the potentiometer, we can nullifying the output voltage by using these two pins, fifth pin and first pin. And next pin, inverting input terminal. So this is the one of the input inverting terminal. The signal applied here will be inverted at the output. Next, the third one is the non-inverting terminal. So here, whenever you are applying input to this pin, the output is in phase with the input signal. And next one is the fourth one is the negative power supply. So this pin is connected to the negative power supply. So operational amplifier consisting of two supplies, that is positive and negative. The negative supply is connected to the fourth pin. And so maximum you can apply the voltage is either 12 volts or 15 volts, minus 12 or minus 15 volts. Next, coming to the first and fifth pin. Potentiometer is connected in bit first and fifth pin to adjusting the offset voltage. So to adjusting that output offset voltage, the potentiometer is connected in between first pin and fifth pin. That is the offset null to nullifying the offset voltage. And sixth pin, the output is taken from this pin. This is the output pin, one pin. And next, seventh pin. The seventh pin is nothing but positive supply voltage. So here also the maximum range is plus 15 volts. You can use either 12 volts or 15 volts. And eighth pin is nothing but NC is nothing but no connection. So internally this is not connected to the anyone. Usually left open pin. So this is about pin diagram. Totally it consisting of 8 pins, but in those 8 pins, 8th pin is not connected to any connection. Out of these, mostly used only 5 pins, 2 input pins, 2 supply pins, 4th pin and 7th pin, and the single output pin, that is the 6th pin. And first and fifth pins are used to nullifying the output voltage by keeping the potentiometer in between these two pins. So this is about pin diagram. Next one is coming to the characteristics, ideal characteristics of operational amplifier. Means ideal characteristics means without applying any input signal, how the operational amplifier is behaving. So the ideal op amp exists only in theory, but it does not exist practically. So this is the equivalent circuit for the ideal operational amplifier. So ideal operational amplifier exhibits the following characteristics. Those are input impedance is infinity, output impedance is 0 ohms, and open loop gain, that is AV, is equal to infinity, and bandwidth is infinity, common mode rejection ratio is infinity, slew rate is also infinity. So slew rate means it produces a change in output instantly with respect to the input step voltage. Means so input impedance is infinity, output impedance 0, open loop voltage is the infinity, bandwidth is infinity, CMRR infinity, slew rate is infinity. Later on we'll discuss about the each characteristic. So ideally all the values are infinity except output impedance value, that is equal to 0. Coming to the practically, uh, So ideal op amp is existing only in theory, but it does not exist practically. Means practically these whole values are not infinity. So practically op amps are not ideal and deviate from their ideal characteristics because of their imperfections during the manufacturing. So this is the equivalent circuit of practical op amp. So for the practical op amp, the input impedance value is in order of mega ohms, output impedance is in order of few ohms, open loop value is gain. But in this ideal op amp, these maximum values are infinities. But here in terms of mega ohms and high value. So whenever you are choosing the practical op amp, you should check whether it satisfies the following conditions or not. Input impedance should be as high as possible. Ideally, it should be infinity, but practically when we are choosing the op amp, data should be as high as possible and the output should be as low as possible, and the open loop gain, that is AV, should be as high as possible, and output offset voltage should be as low as possible. Ideally this is zero, but as low as possible. The bandwidth value is high and common mode rejection ratio is also as high as possible. Slew rate is also high. So in IC741, op amp is the most popular and practical operational amplifier. So these are the ideally all values are infinities. Practically, those values are as high as possible except output impedance. And coming to the applications of op amp. Operational amplifier is used for linear applications, non-linear applications, and mathematical applications. So these are the all these combination of linear, non-linear, and mathematical applications. Audio, video amplifiers, comparators, differential amplifiers, differentiators, filters, rectifiers, and converters also. So these are the different applications of operational amplifiers. And coming to the parameters of operational amplifier. So different parameters of operational amplifier is input offset voltage, offset current, bias current, output offset voltage. So input offset voltage means it is the input voltage applied between the two input terminals to get output voltage, zero output voltage. So input offset voltage nothing but to get the zero output voltage, the input voltage which is applied in between the two input terminals is called input offset voltage. Means to nullifying the output voltage, we are applying some input voltage between the two terminals. There is the input offset voltage. Input offset current. Input offset current means operational amplifier is having two input terminals. So it is the difference between the currents entering into the inverting and non-inverting input terminals. So it is the difference of the two currents entering at the operational amplifiers. The two currents entering at inverting and non-inverting terminal. Next, input bias current. So it is the average of the currents entering into the two input terminals of the operational amplifier. Output offset voltage. So it is the output voltage present when the two input terminals are grounded. So whenever the two input terminals are grounded, then also some output voltage is present. That output voltage is called offset output voltage, output offset voltage. So these are the parameters of operational amplifier: input offset current, input offset voltage, input bias current, output offset voltage. So these are also different parameters of the operational amplifiers: slew rate, common mode rejection ratio. So slew rate can be defined as maximum rate of change of output voltage per unit time. It is expressed in slew rate equal dV naught by dt, and the units for volts for microseconds. Common mode rejection ratio. It is the ratio of differential mode gain to the common mode gain. So these are the important parameters present in the operational amplifier. Thank you.